Now we're almost to the end. So we've looked at expanded, factored, domain, y-intercept, root, and whole. Now we're going to look at finding the horizontal and the vertical asymptotes. Okay, so just to refresh your memory, an asymptote is a line that the function approaches from either direction, but will never reach. So I've got a vertical asymptote, which is, the vertical asymptote, which is up and down, and then you have your horizontal asymptote. Remember, horizontal goes along the horizon. On the vertical asymptote, your equation is going to be x equals, because everything on that line is going to be the same x coordinate, and your horizontal asymptote is going to be y equals. So we need to find how do we find these asymptotes? Well, we're going to do the horizontal asymptote first. And for the horizontal asymptote, what you're going to be looking at is you're going to be looking at the lead terms, and I'm looking for the papers here. You're going to be looking for the lead terms of all of your functions. And we're going to go back to this page right here. Okay. In fact, I'll do a different one. Let's just do a different page altogether, so that'll be a little bit more helpful for you guys. So we're going to be looking at the horizontal asymptote. The horizontal asymptote is going to be the asymptote where you have a horizontal line which has every point on it that has the same y coordinate that the function will never reach or touch. So in order to find that, there is a shortcut. For the horizontal asymptote, and we'll put it here, the best format for your function to be in is expanded. You want it to be in expanded format, so you want it to be expanded. That's the easiest way to find it, okay? So you want your function to be expanded, okay? What you're going to do is you're going to look at the lead degreed terms. Now the lead degree terms are going to be your highest degree. Now what that means is if you have x cubed, then you're looking at the cubics. If that's the highest one you have, that's the highest degree term, x to the third, then you're going to look at all the x to the thirds. If x squared is the highest degree term, the highest exponent you have for your variables, you're going to be looking at x squared. So with that being said, let's look at some of these examples. So I'm going to look at number 1. And number 1 is x minus 4 over x plus 2. So in order for me to find the horizontal asymptote here, I'm going to look at my two lead terms. Now here are my two lead terms. My two lead terms are x to the first. Okay? So I have x and x. What are my coefficients for these terms? 1. So I'm going to do 1 over 1, and that gives me 1. That's it. That's my horizontal asymptote at y equals 1. So I'm going to come back over here, and I'm going to write it down. My horizontal asymptote here is going to be at y equals 1. Y equals 1. Okay. So with that being said, we're going to look at the next one. So I'm going to look at number 2 now. So for number 2, I have x plus 6 over x minus 6. I'm going to look at, again, my lead degree terms, which are x and x. So I've got 1 and 1, which again is 1 over 1. And we'll use the correct color this time, which is 1. So my horizontal asymptote is at y equals 1. Okay? Y equals 1. So now let's look at the third one. Let's look at number 3. So we're looking at number 3 now. And number 3 is 2x plus 5 over x minus 1. So let's look at our terms here. My lead terms are 2x and x. I look at the coefficients. There's 2 over 1, which is 2. So my horizontal asymptote is at y equals 2. If I look at number 4, now I'm going to use the correct, well, we already have, I did correct the factored form for this, but the standard form or the expanded form is negative 4x plus 2 over negative x plus 1. So again, I'm going to look at the lead terms, the coefficients. I've got negative 4x over negative x, so that's negative 4 over negative 1, which will come out and give us positive 4. So our horizontal asymptote for that one is y equals 4. And you kind of get in the hang of how this works. So let's move on to number 5. And on number 5, we have x plus 4 over x squared plus 4x. Well, what is our highest agreed term? It's an x squared. But I don't have an x squared in the numerator. What do? Well, you have to rewrite it with a placeholder. Whatever's missing, you just put a 0 for it. So the numerator, I'm just going to write it as 0x squared plus x plus 4. And the denominator stays x squared plus 4x. Just because it's not written there, doesn't mean I can't put a placeholder. So now it becomes 0 over 1. I'm putting the 0 there because there is no x squared term. So it is 0. So you get 0 over 1, which is going to be 0. So your horizontal asymptote here is at y equals 0. Same issue you're going to run into on number 6. On number 6, you've got x plus 1 over x squared minus 2x minus 3. Once again, I've got a squared term, but not on the top. I've got to put in my placeholder. That becomes 0x squared, since there's not one there, over x squared minus 2x minus 3. So I got to do my highest agreed terms. I get 0 over 1 again, because that's 1, which again puts me at 0. So number 6 also has a horizontal asymptote of 0. Now let's look at number 7. So for number 7, we have x squared plus 2x minus 8 over x squared minus x minus 2. Again, you look at your lead degreed terms, which in this case would be x squared and x squared. Those are 1s. So I've got 1 over 1, which equals 1. So for number 7, y equals 1 is your asymptote. Let's look at number 8. On number 8, you have x squared minus x minus 6 over x squared plus x minus 2. So we're going to look at our lead terms, our lead degree terms, which is x squared and x squared. It's 1 and 1. So 1 over 1 is 1, which is 1. So we've got another asymptote at 1. So let's look at number 9. I'm going to go ahead and skip ahead to number 9. I'm a little low on battery. So on number 9, we have x squared over x squared. That again is going to be 1 over 1, which is just 1. And for number 10, I have x squared on the bottom but not on the top, so you would have to add that placeholder, 0x squared. So it would be 0 over 1, which is 0. So those are the horizontal asymptotes. And again, the way you find the horizontal asymptotes is you put the highest agreed term and match them up and put the coefficients on top of each other.